Good day everyone, this is me Tihana Imbale from BSed Science 3 of Baisakandi High. So for today's video, we're going to have a problem solving pertaining to the lesson entitled Heat Engines. A device that converts heat energy to mechanical work is called a heat engine. All heat engines make use of a substance inside them that undergoes cooling or heating, compression or expansion, and sometimes change of phase. This substance is called the working substance of the engine. Basically, all heat engines follow this pattern of operation. Heat is supplied to the engine by an external source called hot reservoir or heat source. Part of the heat is used to do work on an object. The rest of the heat is released at a temperature lower than input temperature to an external place called the cold reservoir or the heat sink. All engines follow a series of processes at the end of which it is returned to its initial state. This series of processes is called a cycle. Moreover, the heat engine could operate in the reversible process. In this case, work is applied to the engine. Example of it is a heat pump. Heat pumps extracted energy from the cold reservoir, transferred it to the hot reservoir. In order for you to understand the said topic, let me elaborate it to you through showing you a step-by-step process with a sample problem I made. So without further ado, let's get started. I have here a sample problem I made about heat engine and heat pump. We will focus first on the heat engine problem solving activity. Let's start. Engineer Legaspi designed a heat engine that can absorb 8,000 joules heat from the hot reservoir and supplied 4,400 joules heat to the cold reservoir. How much work performed or done by the heat engine? Calculate the thermal efficiency of the heat engine. Before solving it, we will get first the given. So the given are QH, or the heat from the hot reservoir, is 8,000 joules, and the heat coming from the cold reservoir is 4,400 joules. So in this problem, we're going to get the work done and the thermal efficiency of the said heat engine. So now we're going to solve first the work done by the heat engine through using this equation. Work done by the heat engine equals QH minus QC. So let's substitute the givens. QH is 8,000 joules minus 4,400 joules from QC. So the answer is 3,600 joules. So the work done by the heat engine in this problem is 3,600 joules. So now we're going to calculate the thermal efficiency of the heat engine by using this equation. Thermal efficiency equals the work done by the engine divided by the QH, or the heat coming from the hot reservoir, times 100%. Let's substitute all the given. So the work done by the heat engine is 3,600 joules divided by the QH, which is 8,000 joules times 100%. So 3,600 joules divided by 8,000 joules is equal to 0.45 times 100%. So 0.45 times 100% is equal to 45%. So the thermal efficiency of the heat engine is 45%. Now let's go on to the heat pump problem solving activity. A heat pump used in an office absorbs 10,000 joules heat from the hot reservoir and transfers 5,000 joules heat to the cold reservoir. How much work done by the heat pump and its COP, coefficient of performance, or cooling mode inside an office? So before solving it, we will get the given. The given are QH, or the heat coming from the hot reservoir, is 10,000 joules. QC is the heat coming from the cold reservoir is 5,000 joules. So in this problem, we will going to get the work done by the heat pump and its COP, or the coefficient of performance. First, we will solve the work done by the heat pump using this equation, same with the problem number 1. So work done by the heat pump equals to QH minus QC. So let's substitute the given. QH is 10,000 joules minus 5,000 joules is equal to 5,000 joules. So the work done by the heat pump is 5,000 joules. So next is we will going to calculate the COP through using this equation. So COP is equal to QC over W. So QC is the heat from the cold reservoir, and W is the work done by the heat pump. So let's substitute it. So the QC is 5,000 joules divided by the work done by the heat pump, which is 5,000 joules also. So 5,000 joules divided by 5,000 joules is equal to 1. So the COP, or the cooling mode inside an office, is equivalent to or is equal to 1. So that's all for today's, guys. Hope you'll learn from my discussion. Thanks for watching. God bless.